Right, so I hope that you have marked your hyperbola exercise and that you understood everything about the hyperbola. Today we are going to look at the exponential function, and first we are going to look at what you have done in grade 10. So in grade 10, the exponential function formula that you had was a times b to the power of x plus q. Now, a and b influences the form of the exponential graph, and there are many summaries about this, but this particular summary works very well for me. If a has a positive value, it means it is above the x-axis. If a is negative, it means that the graph will be below the x-axis. Now, if b is greater than 1, it means that it will either peak on the right-hand side or it will go down on the right-hand side. So greater than 1, everything happens on the right-hand side of the Cartesian plane. Right, so if b is between 0 and 1, which means it is a fraction, everything happens on the left-hand side of the Cartesian plane. It will either peak on the left-hand side or it will decline on the left-hand side. Okay, so what else did you learn? You learned in grade 10 that the q value is the movement up or down. Exponential is an x. It's like a relationship. You only hopefully have one x. So there's only one asymptote, and that is y equals to q. There is no line of symmetry. And then to get the x-axis, you will get y equals to 0. This will lead to exponential equation. To get the y-axis, you make y equals to 0. Remember, anything to the power of 0 is 1. The domain is always x is part of real numbers, and the range is always, it's either greater than q if it's a positive going up, or it's less than q if it's a negative and going down. Okay, so what are we going to change in grade 11, as we did with the parabola and the hyperbola, is we are going to use exactly the same formula, but there's a p-value added. Now, as with the parabola and the hyperbola, what does the p-value mean? If it is plus, it will move left. If it's minus, it will move right. Okay. So let's look at the examples. In your notes on page 20, you will find these examples. I'm quickly going to walk you through them. So how do I sketch this exponential graph? I start with the asymptote. Now the asymptote is at minus 2. So on my graph with little dotted lines, I am going to write y equals minus 2 because that is the line that my graph is not allowed to cross. Okay. So, if I had to refer to the formula, a times b to the power of x plus p plus q, in this point, my a is times by 1. So, a is positive. Okay, if I look at my b is greater. So, I know my graph is going to do that. Now, for it to do that, I need two intercepts. So if I work out the y-intercept, I'll make x 0. So y is equal to 2 to the power of 0 plus 1 minus 2, which means I will have 2 to the power of 1 minus 2, so y is 0. So that means the coordinate is 0 and 0. If I work out the x-intercept, now in this case I would have realized it's already 0, but let's see what happens. If I work out the x-intercept, I'm going to say y equals 0, I'm going to move the minus 2 to the right, and it becomes plus 2. Okay, which means I am left with a exponential function, so exponential equation. So 1 will equal x plus 1, so x works out to be 0. So there's my point. So the other alternative I have, or what I have to do, is use my calculator, and I'm going to say 2 to the power of x plus 1 minus 2. I'm going to start at -5, end at 5, steps of 1. So I get at -5, I'm going to have minus 1,937 minus 3. I'm going to have minus, I'm just going to add that, minus 1,75. If I go down, minus 2, that's maybe a better point. It's minus 1.5. Minus 1 and minus 1, that's a definite point. Then I have 0 and 0, 1 at 2, and 2 will go up to 6. So when I draw my exponential graph, that is how it's going to look. Right, no lines of symmetry, but I can write down the domain. X is part of real numbers, and the range is the important one. Y will be greater than minus 2, and y can be all real numbers. If you wanted to write it interval notation, exclude minus 2, go to positive infinity. Simple. Right, let's look at number C. I'm going to do number C now. So for the first step, I'm going to add my asymptote, which is at 2. Y equals to 2. Just add some color. That's who I am. Right, so when I look at this, if I had to rewrite this using a times b to the power of x plus p plus q, I can write it as minus 1 times by 2 to the power of x minus 3 plus q. So my a value is negative, meaning I am going to be below the asymptote. My b value is greater than 1, which means everything happens on the right-hand side of this graph. Okay, so I'm going to do my y-intercept, make x 0, y is equal to minus 2, 0 minus 3 plus 2, which means I have, let's keep it, minus 1 times 2 to the negative 3 plus 2. So I can write it as minus 1 to the times 1 over 8 plus 2. And then minus an eighth, if I quickly use my calculator, minus an eighth plus 2 is going to give me 15 over 8, which means it's 1 and 7 over 8. So on my y-axis, round about there, I'm going to have a, apologies, a y-intercept. X-intercept, make y 0. I'm going to move the minus 2 to the power of x minus 3 to the left. Now I have an exponential equation, which means x minus 3 equals 1. Therefore, at x4, I am going to have my x-intercept. So on my calculator table mode, y is equal to minus 2 to the power of x minus 3 plus 2. I'm going to start at negative 5. I'm going to end at 5 in steps of 1. Right, so let's first look at the values. At 1, I have 1.75. That's about there. So I'll need to go back to the top. Minus 4, I'll be around about there. So minus 4, I'm going to have 1,99. This is 1 and 1.75. Then I'm going to have 2 and 1.5. 3 will be at 1. And if I go to 5, 5 will be at minus 2. Now I have given my marker enough values to mark my question. Okay, number D. Now I have a half. So in terms of y equals a times b to the power of x plus p plus q, a is 1. So a is greater, it's going to go up, but b is less than 0. So it's going to go above the asymptote, but it's going to go up on the left-hand side. So I see there that my asymptote is at 2. Y equals 2. Do I need to work out an x-intercept? No, because from looking at the equation, it's going to go up to the left-hand side, so it won't go through. The only one I can work out is the y-intercept. So I'm going to make x 0. And that means I'm going to have, please don't ignore that, anything to the power of 0 is 1. So at y3, I'm going to go up. Right. So if I put in my equation, half to the power of x plus 1 minus 2 plus 2. I'm going to start at minus 5, end at 5. So when I look at my values, minus 5 is at 18. I can't put that down. Minus 3, if I add a 6 there, I will have minus 3 and 6. I will have minus 2 and 4, minus 1. Oh goodness, let me quickly just re-enter it here. A half, somewhere I did something wrong, to the power of x. Oh, here's my mistake. Here. Sorry for that. That's x plus 1. So 0 plus 1, that means that is a half. I apologize for that. That's at 2.5. And you see how I picked up on my mistake. That is 0 and 2.5. I apologize for that. Plus 2, and let me just carry on. 1, I will have a value of, this thing is not playing along with me today, 1 over 2 to the power of x plus 1 plus 2. There we go. This calculator is also under lockdown. 1 is at 2.25. I don't like that point, but let's just plot it. And coming closer to 5, it is just above. So my exponential graph will be doing that. Okay, domain, I will have x greater, well, part of real numbers, and range y will be greater than minus 2, and y is part of real numbers. Okay, next question. So this one is a very tricky one because now there's a definite a value, definite b value, but the b is to a negative. We first need to try and make that a little bit easier on ourselves. So I can rewrite this saying 2 to the power of, take out a common minus. So I have x plus 2 left there. Why am I doing that? Because I want to be able to say 2 to the negative 1 is actually a half. Therefore, a half will be raised to the power of x plus 2. So a is greater than 0. It's above the asymptote. B is less than 1. Less than 1, but greater than 0. Okay. There as well, less than 1, greater than 0. So it will happen on the left-hand side, and my asymptote is at minus 2. There is my asymptote, and that is at negative 2. Right, so 2 times a half to the power of x plus 2 minus 2. Start at minus 5, end at 5 steps. Right. So at minus 4, I will have a value of 6. Minus 3, I will have a value of 2. Minus 2, oh yes, I could have worked out the x-intercept. Minus 1 and 1. 0 and minus 1 comma 5. And then it goes there. Right, so if you don't want to use your calculator, y-intercept, x equals 0. So y is equal to 2 times a half, 0 plus 2 minus 2. That means I have 2 times a half squared is a quarter. Okay, that means I have a half minus 2, and that's how they got to minus 3 over 2. If I wanted to work out the x-intercept, make y 0, I'm going to move the 2 to the left, so I have 2 times a half to the power of x plus 2. 2 divided by 2 is 1, so I'm going to have a half x plus 2. That means I can write it back as 2 to the negative x minus 2, and 1 can be written as 2 to the 0, and that's how I get x is negative 2. Okay, so your homework for drawing exponential functions is exercise 7, number B, E, and G, and you'll have your answers loaded already to check your work. I just need to do one last thing in this lesson and speak about transformations. How does transformation affect functions? Well, you have two. You have reflections and you have translations. What happens with reflected? So if it's reflected about the x-axis, as I said previously, remember this by thinking about a relationship status. If we're happy together, we have the same friends. But if we break up, everyone is affected because they have to choose whose side they're going to take. So therefore, over x-axis, everyone is affected because that minus will have to distribute in. And a y, I'm asking the question why only the x terms has a change of sign. Now translations, we've been doing it the entire time. Is the movement left or right, or the movement up or down? Left or right is the p-value, and we work in the opposite direction. So if we move to the right, we will basically subtract, because moving to the right is a minus p. If we have to move to the left, we will have to add to the existing p-value. If we move up or down, it's plus or minus to the q value, just as it is. These type of questions, you will notice we get to do them in the following exercises going forward. I hope you have a lovely day. See you next week, Monday.